Morning everyone, my name is Yuri and we're streaming again. Let me know about the sound, the visuals, and let's get started with some coding. Morning everyone, and while we are checking this stuff is working, I'm gonna pour some wine. So hopefully it's alright. Hope you have a good morning too. I'm not sure how much I will drink this morning. It depends on the complexity of the effects we will be facing. Hey everybody, let me know where you're from. It would be nice. Hey to the France and to the Texas as well. Morning everyone. Alrighty. Yeah, just someone say, it's alright, I can hear you. Now let's get going. I still have all those doubts like whether it's streaming good or not. Morning everyone. Sup Ireland. Yeah, I'm constantly upgrading my stream and now I have lightning, you know, you can not only see me in high quality, but I don't know, I'm lighted properly. Hey to the Amsterdam, nice to see you. Kazakhstan. Perfect. So I'm gonna switch the screens. I'm gonna show you one small trick before. This is gonna be the website we're gonna be trying to do today. Serbia. It's a pretty big geography now. And while you're mentioning all the countries, I'm gonna show you a small trick that I learned as a streamer, you know. So watch this. And then voila. I bet you didn't expect that. Well, alright. I need to get back. Okay, jokes aside, we need to start coding. I think I gotta be smaller version of Yuri. Yep. Hey, pretty popular in Amsterdam. All right, so we're gonna do this website, and this is a really cool website by Mark Appleby, as you can judge from the domain. And yeah, it's pretty cool. I advise you to go check it out because this is one of the websites that I had fun like just interacting with, and it's like a story. Like it's not like you pushing the portfolio button then you see the list of the projects. It's a story like experience that you get into this website. And maybe we will do some other effects from this website later on, but this stream I kind of decided to like step back from all those WebGL because we're getting too deep into all those shaders, and in the end it actually doesn't really matter what tech you use to implement this or the other effect. It's just some simple math in your mind, and then you just draw those things with SVG, I don't know, Canvas2D, DOM, anything, maybe in like, I don't know, any other tool like open processing or some projections, anything. Yeah, wine is much better. It's good. It's Chianti Merlot. I think it's not Chianti, and I expected it to be Chianti, but I messed up. I'm not good with wine yet. Yeah, it's gonna be simple, man. So there's on this website there's WebGL, like obviously those treasure chests are WebGL like because they are 3D, but then there's this small magic thing, and let's try to do this one and maybe try to grow it into something even bigger than it was here. And the thing I wanted to implement here, even though I'm gonna try to use two-dimensional animation today, I'm gonna try to implement signed distance field functions. So SDF functions would be implemented in this stream in Canvas2D. I don't know why, don't ask me. Well, you might ask me, I'll tell you just in a couple of minutes, all right. So let's get started. And you know, the other thing that I really like about like making this particular animation is that you don't need like anything. I mean, you you need a PC and some text editor, but you don't need some setup with Three.js, with WebGL. You just need text editor, and that's it. And I'm gonna start from real scratch. And I'm gonna call them magic. Yeah, just mentioned that I could do magic, so let's start with magic. So I'm gonna go to the folder magic, open it up in a Visual Studio. I'm gonna create the file. I'll probably, because FarColor is in the chat, I need to do the Windows setup. So the code is gonna be on the left, and then the visual is gonna be on the right. So at the very moment you would be able to see my screen in my code. I think we don't need as much visuals. It's more coding stream than watching stream. All right. This is the Windows setup, the custom-made, handmade setup. It's never too early for a wine, I think. And especially if you're feeling a bit sad, well, don't overuse wine, but still, I'm only using it once a week. So I'm gonna create the index.html file. That's where we start. Then I'm gonna just do the basic version of the HTML. Okay, I don't need. I'll probably hide the left panel in a moment, so you'll be able to see more. And then I'm gonna create. I'm not gonna even create in Canvas. I'm just gonna create script. What HTML code I have become? I'm just coding script app.js and that's it. Okay, and then I'm gonna create app.js. And then inside the Visual Studio Code, you have this open live server. Okay, why would you open it here? So I can just open it up and, well, yeah, I see the amazing complex pages that we just coded. So let's just, the first thing that I usually do. And yeah, it works. It works all right. It's auto refreshes. It's perfect. I don't think we're going to be needing any other files in a while. This should be enough for now. So let's just, like, I imagined that if I'm going to be on some island and no one to communicate with, I don't have any access to the internet. I just have access to the text editor and my laptop is fully infinitely charged and I can do anything. So that's what I would be doing on that island. I'm going to be experimenting with particles. So it's going to be, I'm going to create the canvas first. I could of course have typed it in the HTML, but that's not how cool guys do this. Then I need to access the, I think this stream would be nice for anyone to get started in Canvas2D. This was the first kind of thing that I did in terms of animations. I just used Canvas2D and some particle magic. And then how do you get the viewport site now? Viewport size JS. It's like document element something. What's the vanilla? Yeah, it's this, right? Why do they make it so long? So it's gonna be width and then the height. Then I need to add this canvas to my body. Or it's a pen child, right? And I'd like to set the dimensions equals width, and then the same for height. And well, hopefully I see something. So yeah, we have the canvas, the size of the viewport, everything is good. What else? Let's try to draw something. So it's kind of basic, really from scratch kind of thing. But let's see how far we could get in 1 hour. I'm gonna just do So yeah, it actually draws something. Now let's create a loop. So I need some time. I need some time. Yes, I need some time. Okay, and I'm gonna move through time. And then I can draw this kind of thing right here and just add some time. Yeah, it does work. That's perfect. And now I can do something like, I need to clear, it's clear rect, right? With height. And now if I add time here, it's gonna be, yeah, maybe probably this. Yes, it's gonna be moving now, because without this thing, it's gonna be drawing all over the place, like all those rectangles, and it's not fun. Yes, sure, I'd be glad to see the... Oh, Chuck Norris just joined the stream. All right. All right. Yeah, it's gonna be some magic show today. Yeah, I'd be glad to see the link that you will quote, Anthony. So of course send it to me. Maybe just tag me on Twitter or anywhere, so anyone would see. Okay, so now we have the like basic stuff. It's not good, and I kind of like to convert this one to some kind of class, because I'm used to doing classes in JavaScript. So it's gonna be class sketch. It's gonna have constructor with all those initialization probably going on there. Just really fast converting this whole thing to the classes. Here. Gonna do this, and then I gotta beam this, so we see this one. This time equals 0. Am I going too fast? I don't know. Sure, this time plus. Let's lock this time. And then let's move all the drawing math. Should say math. And it's gonna be these contexts, and like this all over the place. And then I don't need this at all. And then maybe just run this one. We have some JavaScript errors here. Canvas is not defined. Yeah. So it's the same thing, it's just converted to the class. All right. Now I kind of want to do the mouse thing, mouse move. I need to get my mouse inside this canvas. So to get this, I'm gonna do what? I think I have this canvas, mouse at event listener, mouse move, something, log that something. I don't need time anymore. I've had enough. And then now I keep always forgetting, like, how do they name those? It's either client-x or offset-x, and I think it's client-x. So the client-x is, I'm gonna move my mouse to the top left corner and see what was the last number. Anything not to read docs. I could do anything. I could move my mouse precisely to the left top corner just to see the numbers. So it's client X and then it's page X. What's the difference? I think one is relative, one is not. I think it's client X, to be honest. So it's gonna be, and then, well, let's maybe like this x equals 0, this y equals 0, and then this x equals y. And then instead of positioning my rectangle into the 0, 0 time thing, I'm gonna, but this. I'm gonna position him at this. So now we have the magic. Well, this is almost magic. Like, you could imagine that this could be a magic wand instead of the just black rectangle, if you have enough imagination, probably. Yeah. So how do we do those fancy particles? Well, obviously obviously we need to create another JavaScript file. It's gonna be, we're not gonna be using bundlers though. And let's do this export default particle. I'm gonna create some entity, something. I'm gonna create something. And this something is gonna be, it's gonna have the constructor and draw methods, and then inside the constructor probably gonna be x and y, and then this x equals x, this y equals y. So I'm creating some particle, and when I'm gonna be drawing it, I'm gonna use this context of my canvas, and then I'm gonna just draw rect x, this y, and then like I need some size. So now when I create the particle, and if I have some array of particles, if I just loop through them and draw them, they're going to be staying in some places. Let's just try to do that. So I'm going to create these particles equals some array, and then when I'm going to be moving mouse, I'm going to be these particles push new particle, and then this x, this y. I don't yet have any particles, so I need to, what? It's like the Visual Studio Code just did that for me. How did it happen? I wanted to write that code myself. Well, anyway, as you might guess, you could just import local files. Will it be, does it work though? Oh yeah, this is the other error. How did the Visual Studio Code guess that I would import that file? Requires not defined. Yeah, well, I don't know how it did that, but did it wrong. So you could just use the native imports probably in this particular case. We don't really need the, yeah, but we need one small thing here. Will it work now? Unexpected token. This is somewhere in my particle. Yeah, it works now. I just forgot the class name. So we could use the native imports. We don't really need some webpack or something. Well, if you're just testing something locally, you just could use those. I also think all the 3JS examples right now is based on this kind of imports. Yeah, there's probably some feature inside the Visual Studio Code. At what point did it include that code? It didn't work for me though, but that still was kind of nice. So now we have the particle. Now we are just adding those particles, but we're not drawing them. What we need to do, we need to loop through those particles. Now I don't need file explorer anymore. These particles. And then p draw. Nothing happens. And that's because what? I think Chuck Norris was so good that he wrote that code for me. Okay, these particles probably get some error. Cannot read for each of undefined. These particles. Yeah, I should probably move it here. Something is wrong still. Not sure what exactly. Cannot read property draw rect. This is not draw rect probably, but fill rect. What have I done wrong? Okay, I'm not using the canvas inside my draw method, so yeah. Still something is wrong. Cannot read property fill act. Come on. And still something wrong. So just added one particle and that's it. Why? Why though? Because I think I should have been adding them on each mouse move. And like this particle, okay. I need to remove console logs. I don't need this anymore. So just array of 1. And why is that so? Oh, it's because it's the CDX, yeah. Fuck. Yeah. So now we could draw something with our canvas, yeah. But they're not moving. They're not moving anywhere. So let's just add some random velocity to our particles. This velocity x equals math random. Let it be like any kind of velocity, so it might be negative. So this one's going to be between 0.5 and -1 and 1 in the end. This one between 0.5 and 0.5, -0.5 negative. And then, yeah, inside the draw method, I'm going to just be adding this x plus this velocity x, this y. This is where the magic happens. So now they're gonna be living their lives. Equal, like, we should probably add some death now, because we just added the life and this is too much life for my PC to handle. Well, this works all right. What's wrong with my PC though? It's like trying to... Something bad is happening with my PC. So I'm adding too much particles or what? So we should probably not think about removing those particles because it's just adding too much of them. I'm gonna add the concept of life now. Life equals, let's say, 10. And then on each draw step, I'm gonna do this life minus what? So this is actually like right now, if the life is 10, on each frame I'm gonna be subtracting something until it gets to the 0. So let it be like something like 0.1. And so when this p life greater than 0. So we're still drawing this thing. That should probably disappear. It's not quite good because we still grow in this particles array, so we probably need to remove it from there. And I think there were some problems, like, okay. I think it's gonna be probably just splice function, and I just need the index. But I think there were some issues, like when you're looping through the array and then you're removing something at the same time. Maybe I don't really care about the issues because I'm gonna be having a loop, and on the next step it's gonna be alright, so I can just do this splice index. I can do this. Let's just see the length of the array. Okay, I'm outputting too much things. Oh yeah, that's probably the reason. The console logs. They're using so much performance if you just use the console log. Yeah, I don't really care about this huge black rectangle anymore. I'm sorry. Huge rectangle. So we could have like 100 particles and then they grow into 0, you see? Like, and then they are slowly dying, just like everything good in our lives. No, I'm just kidding. Because we can now grow the good things ourselves. And I don't know, I can make them live longer. I'm the god on those particles. Well, just on those particles, but still. So, it's kind of like almost there, right? So it's the magic wand and some particles, but it's not that. It's all in the small details. First of all, I'm gonna need colors. So I'm gonna do this. Where's my color snapper? So I'm gonna have the color array. I'm gonna take them from Mark because I bet Mark spent some time picking up those colors to look magical. And by the way, this is like, I think, my way to give, I don't know, maybe kind of a shout out for developers, but it's because not everybody posts like how they did this or that, and I hope Mark doesn't mind me decompiling this stuff publicly. So I have those random colors and can do like random color thing, which is gonna be returning us these colors, and then math floor, math random multiplied by this colors length. So it's gonna be just picking up the random color for us. Perfect. This is gonna be picking up a random color for us. It doesn't yet look actually nice. It's just like living particles, like where they were. It's not yet there. Not yet there. So let's move on. I need some wine. Lerp? What exactly you want to use lerp on them? Well, we could of course use lerp. Well, this is some kind of basic lerp, by the way. Like what we're doing here is basically just lerp into 0. There are 2 or 3 things still missing from making them magical, and well, one of them is the colors. Okay, let's use colors. I'm gonna just use here like random color. This random color, and then I need to use it here. Probably a better way to handle this is to first translate, save. And then restore. This is a way, just another way of drawing things. And now we could use 0 system of coordinates here. This is just easier to think about. And then let's see, do we have colors? And we do have them, but maybe we should add black, because without black it's too damn bright. By the way, I forgot the hash. So now it looks kind of like a magical particles. It's not yet there because it lacks 2 more things that I'd like to add. And one of those I think is kind of brilliant. Brilliant thing. So first of all, I think we like gravity. Gravity equals 0.5, let's say. And then I'm gonna grow this gravity. So this gravity is gonna be, it's like the acceleration, and that means that it should be growing speed the whole time. But I'm gonna simplify things, and I'm gonna just add something small to my gravity, and then this thing I need to add to y velocity, because gravity is usually a vertical kind of thing. Well, this is a nice effect, not what I expected at all, but still kind of nice. It's obviously not here at all should be placed. I just messed up the things. It should be placed right here when we add in the velocity. And now we have some kind of gravity going on, right? Well, there are different ways to handle the particle lives, because we could just, right now I'm handling in terms of time. You could also handle in terms of position, like once they hit the border of the screen, you would remove them then. But the only thing that like is changing is that you're gonna be, instead of comparing life, you're gonna be comparing X position or Y position of the particle. So it's not that complicated. Well, the other thing that we need to do, we need more particles, because it's not that much. We need them more. So instead of creating just one particle here, I'm going to create a small loop. Maybe 6. And then do it here. It's now way more particles, still 60 FPS, works perfectly fine. Now I could just handle their sizing. Maybe make gravity a bit less, and the first gravity should be 0. We're going to be adding it anyway. It's kind of small gravity. But let's handle the size of the particles. So we have this size, and it should probably be dependent on the life. So life changes between 10 and 0. So we could do the same with the size. So this size is going to be equal this size multiplied by, not really multiplied, like the default size is, let's do this default size, and then this size is going to be default size multiplied by what? And this max life, probably I need this, multiplied by this life divided by this max life, right? So now we have some kind of fireworks, I don't know, something like that. But the thing is, I think they're moving too slow. Like we need to intensify the speed. It looks more like magic already, right? Almost there. And it's cool, they're not disappearing now, just like barely disappearing. They're just slowly fading into the void. Yeah, and this is what I find brilliant. Like now, Nilesh, I'm sorry if I pronounce your name wrong. So what the mark has, and like this is also awesome, and this is the simplest way to create the particles. But you could see that when you could see closely that the particles go in some kind of fixed directions. So it's not just complete random. It's like 3-4 direction. If I go from bottom to top, you could see that it's like some separate direction. It's not complete chaos. And this is actually, I think, one of the rules of something beautiful. If you have something in chaos, you just should bring some little bit of order into the chaos, and it's gonna be beautiful. So the beauty is usually something on the edge of the chaos and order. So right now we have the chaos here. So these complete random particles going in random directions, and they don't really dependent on the mouse movement whatsoever. So we could do two things. First of all, we're gonna make them dependent on the mouse movement. So we're gonna have this pref we don't actually need that. So I'm gonna use those variables as a previous and like last mouse positions. It's gonna be X and Y. I'm gonna add this X and this Y. This should change nothing. And then in the end, I'm gonna update with X and this Y as Y. What I wanna do here, I wanna separate the current position from previous position, so I have some difference. So I have some like mouse vector. Yeah, I should call it mouse vector. And when I have some mouse vector, I could actually use it to point my particles in some direction. So instead of just creating a new particle, okay, I hate so many braces. I'm gonna do this like velocity X and velocity Y. And I could, of course, move the like velocity X, velocity Y. I need to set them here. And then just to check everything is in place, I'm gonna so it should work the same way. Yeah, it does. This is perfect. Okay, Nilesh, yeah, you're right. And this is what I found particularly beautiful and maybe kind of brilliant and simple idea about this animation and how you could bring a little order into the directions of those particles. Because I spent some time like thinking like, how did he do that? And I think it's really awesome idea and really simple. So right now we have velocities and they're not really dependent on anything. This is just a random point in random locations. What I want to do, I want to make them dependent on the mouse movement position. So I'm going to do this. I'm gonna do like some variables like this X equals X minus this X and Y. Same way for Y. And let's just console log them. I set console log. Just to see this vector. So when I'm standing in place, it's 0, 0. Okay, I have another console log somewhere. Yeah, I don't need this one anymore. So when the mouse stands in place, it's almost 0. But when I'm moving, it's like 10. It's some vector pointing in the direction of my mouse. And this is what I want to use to create the speed of my particles. So instead of just making it complete random, I'm gonna make the randomness, still the randomness gonna be involved. Come on. But I'm gonna add this dx thing here and dy thing here, right to the velocities of the particles. And right now we are sending them the direction that we are moving, which is kind of good. I'm not sure which direction we should send them. Maybe the minus. It's still chaos, but it's starting to get some order now. Well, probably moving with the mouse was a good idea. So right now this speed is kind of big, so maybe I should just divide this by 10 or something. I mean, this difference, the mouse speed difference. Well, it's starting to look better, I think. Maybe it's too much. And maybe it's not a minus. They should have some inertia following the mouse, right? Because it just came out of this magic vent. They should probably follow the mouse vent. So right now we are starting to get something more beautiful. It's still random though, right? And I think the speed is too small right now. Maybe I should make this 2. Because this is just between -1 and 1 now, maybe even 3. Like a bit more randomness. So they have some inertia, they have some randomness. It's still not like, it's not in order. And the thing that actually makes them in order, just like the Mark did, like in those couple of directions, is unimaginable. This trick is just mind-blowing. I mean, seriously. It's so simple. You could already see the pattern inside my particles because I'm just rounding my speed numbers, and of course that depends on the scale you use for your speeds, and in my particular case I think that's not just math floor. On any other case could be something different. We could also add a bit of a randomness to those paths, because if we find them too in order, but this is it. Like, see, if I'm just going from bottom to the top, you could see those trails. And this is actually just the rounding scale. It's like a round in a row, what you could call possibly. But in this particular case, I think it makes it just more beautiful. So the eye just follows the path of the mouse, and yeah, it just makes it more beautiful, I think. So this is what you were talking about, Nilash, right? This is actually already like a magic wand, but let's try to make something. Okay, I wanted to show you how you could use the sign at distance fields function in this particular case. So let's try to use them. So there's another part of this animation. Like when I get further from the animation. Oh yeah, first of all, guys, like this is another mind-blowing performance trick I would show you. If you just go to the Mark Appleby website, and I'm surely would like send him this too, because I just found out this yesterday, like short performance trick from Yuri. Well, from anyone knows it. So first of all, you could see this nice SVG animation. It's really cool, and it's on NPM, by the way. You could use it. It just has one font though. I think Mark developed it himself. It's called MoText. So you could just go to the NPM and see the MoText package here, and you could try to use it. It's beautiful. One font though, but still beautiful. It even has an editor, like where you could set some things about this animation. This is important why I'm telling you this. And then if you go here, you could see that FPS is not, well, you might not see this on the stream, but if you go yourself on the Chrome, on the current version of Chrome, you could see it's just 30 FPS here. So I could just bring back my FPS extension, and you see the FPS is just 30. It's not actually, if I stop doing anything, it's again 60. See that? Magical thing. And you know why? You know why this is happening? If you go into the performance tab, hit the record, let's see the 40 FPS. Let's stop that. And if you go into the CPU thread, it just barely nothing, just, I don't know, 4 milliseconds. That's okay-ish. But we still see the like 40 FPS, 30 FPS drop. And this is because if you go to the GPU, you will see the GPU spends like 20 milliseconds on each frame. And why is that happening? Maybe you could try to guess. Well, I'll give you 10 seconds to guess. And while that, I'm gonna fix this issue with just one line of CSS. Because I already experienced this kind of thing. Mark did everything right. What is wrong here is the automatic browser behavior, which sometimes is not really optimal. So there's this home wrapper, which just takes this SVG animation. And if I just go here and do I'm gonna just separate it into another layer for rendering. And you could see we have perfect 60 FPS now. Because all this time, I think, that's what I think. All this time, I think the GPU was rendering like this whole screen. It didn't separate like those layers. So it was re-rendering the whole layer. And because there's pretty complex SVGs here, like those one, that's a lot of paths here and masks and duplicates. It just takes a lot of time for GPU to render those, to repaint those, and or maybe to composite them into the other layer, I don't know. So the basic thing is that you just need to separate those layers of animation. So the browser would handle them separately and this SVG would not be involved in any way in this animation. And now you will get the perfect 60 FPS on this animation. So this is kind of important thing to remember when you do the background canvas animations. And this is the kind of thing that usually people talk on premium courses on performance and all these kind of things. So this is a really important thing. It's 2020 and this still makes sense just to do those. Don't overuse though, because this has a like kind of a drawback, like using this transform 3D actually separates to another layer, but that layer now takes more memory, I think. So if you do this, if you overuse this on the phone, it's going to take a lot of battery usage and something like that. Yeah. So don't overuse it. But this time I think it's just on the desktop especially. All right. And the other thing, SDFs. So what is SDFs? SDF functions, they're just saying like the distance to some object in two-dimensional space. So it's like each point we could calculate the distance, the closest. I mean, this is just the definition of distance probably. So just the distance to this object, like the closest path that you could walk towards it. And what I wanted to do, like why this idea came to my mind, because if you just do something like this, like div h1 super title, and then position it into the center, just some green title in the center. Okay, it's too long. Why did it go to the another line? I think it had pretty much enough space. Yeah. So if you go this title, and then you want to do some kind of animation, but you want this animation to be dependent on the distance, just like Mark did actually. You could see that the particles, they're fading away when it's far from the chest. And yeah, they're bright right here, but they're fading away right here around the particle. It's not actually the distance in his particular case. I think it's like just the left-right coordinate. So they just fade independent on the x position. But what I needed in one of my projects, I needed to calculate like I need some animation to happen more intensively when I'm closer to this title. And I could of course try to calculate the distance. Let's just try to do that. And then opacity, and then I'm gonna use opacity here. Then I'm gonna make this opacity as a distance from the center. Let's just imagine that we have a title in the center of the screen, so we kind of want to do like the distance towards the center. Let's try to do this. Let's try to do this. I lost myself in my code. So this is where we initiate the things and then just put 1, maybe it's 0.5 just to test things out. We're not using opacity yet. I'm gonna use it though. We need the RGBA colors probably, and I need to set colors in RGBA. So maybe just the size of the particles. So maybe screw opacity. I'm gonna just do the size of the particles. So it's gonna be size. And we would multiply the size we would multiply this default size with some kind of size. And this is what I'm gonna receive in here. And this size would be dependent from the distance to the center. Right now it's 0 probably, undefined. It's okay now. If it's gonna be like 10, it's gonna be real big. So I want my particles to be big, huge when they're close to the center, and not otherwise. So I'm gonna calculate the distance to center. It's gonna be x like that. Same for height. And then I should divide that one by the maximum distance from the center, which is like the same thing without the x's and y's. And then let's just log. I'm probably overcomplicating things, but that's what you do and everything works. So when we are on the left topmost corner, it's 1. When we're in the center, it's kind of 0. Yeah, it gets close to the 0. And that means I kind of want to do this. This is some magic, by the way. It looks pretty neat if you just stand in place. You could see those rounding things going on. Pretty cool. All right. You could also use images for those, by the way. So what I'm doing here is already advanced, not really often used technique. And what I need to do now, I need to calculate, like right now it's the distance to the center. I'm not using it, okay. And I need to set it here, like 10 multiplied by distance multiplied by 10, so it's hugely impacted. Okay, maybe the other way around. So it's small on the corners. Maybe not multiply this by 10. So it's big in the center and then it gets small in the corners when it's far. But when I'm close here, it's still small, right? But it should be like the biggest one because it's close to the particle. What I'm trying to tell you that this is actually not the distance to this rectangle. And to calculate distance to this rectangle, you would actually need the sine distance field function. This one, actually. It might surprise you. This is a shader function in GLSL, but you're still gonna use this one to calculate distance towards your rectangle. And let's just maybe, I don't know if we should do that. Should we do it in images or SDF function? I'm not sure. Because really, I already told you how to do that. It's just you need to convert this function, the SD box. This is actually just like a nice idea I wanted to share, because like you wouldn't expect to be using some SDF functions in Canvas2D, but obviously you need to calculate that. Yeah. Maybe let's just try to use an image. And we could also use some rotation for the particles. We forgot to use the rotation. This rotation equals 0, math random. Kind of jumping between things here, but hope you don't mind that. Because we're running out of time, I think I'm gonna leave it at that. I'm gonna just add an image. Rotation and SDF functions, it's just an idea that I wanted to put in your mind. That is kind of surprising that you would be using the SDF function there. Spend too much on other things. Okay, this rotation, and then this rotation equals plus something from life, probably. It should be dependent on the life, and then we could do the life random too, like we could do life, just randomize it a bit. And then when we did the rotation, we could do this ctx rotate, this rotation. Let's see. Well, this is well, this is crazy cool. Okay, let's use 10 or 11 here. I know what is happening. I know exactly what is happening, because we are not rotating particles like the wrong pivot center. Now we don't see anything. Invalid token. Okay, the debug is not that good now. Line 17, all right, line 17, I can do that. Oh, yeah. Okay, something wrong with the center. Just remove the rotate. Oh, yeah, fuck. This rotation should always come after the translation. Well, right now it's pretty cool. It's another magical animation. So probably it should rotate a bit slower. That's still too fast, right? Get in there. It's kind of a nice animation, like on itself. It's completely not what Mark did, well, at all. But it's a nice thing to do. I can send particles into different directions. It's kind of fun to do actually with the mouse. You feel that you're interacting with things. And I wonder why this size is so huge for me right now. Yeah, it's much better this way. And maybe rotate them a bit faster now. Yeah, now they're being rotated. It's all good, because life random, they are rotated in random ways. They're dying randomly. So it's kind of cool. And then like the final touch. I think I had the gist. Yeah. It's gonna just load the image and use an image. Not here. It's gonna be the last thing I do. We're gonna go into the SDF today. So we're gonna do I'm gonna take the hue imposter. imposter. Gonna make it square. It's too big, too big, too big, too big. I'm gonna save it. Magic. So we have it. You should probably see it in the console log now. Yeah, we have this array of the loaded images. This is just the simplest image preloader. Like, takes an array of images and then preloads them. So I'm gonna do this image equals images 0 image, and then I could probably use it when I instantiate my particle. So like the first one. And then instead of fill rect, I'm gonna do okay, we need to get a bigger size. And here we go. Just did a lot of imposters. And you could of course do this like a fountain of the imposters or anything, right? Right now I'm just making them the mouse movement. And I think for the tweet DOM I'm gonna do the fountain of the imposters or something like that. You could imagine how you can do that. And well, the important thing here is that we didn't actually use any libraries. Well, I used the preload images, but like it's like because just to not waste time on writing this function on my own. So it's pretty simple, pretty easy. Well, the idea with the title was maybe too much for 1 hour, but I hope you got my idea about the two-dimensional SFDS functions. And it's pretty cool that we didn't use any libraries, we didn't use any bundlers. You just go here and just go crazy with any like velocity on physics. It's just bounded by your imagination. You could do anything with those speeds. You could increase them, like we could increase the X speed instead of making it less, and it's gonna be like a bit more crazy on the sides. On the vertical terms it's gonna be all right, but on the left it's gonna just go crazy outside of the screen. And yeah, you could do like anything here. You could get a bit more like this, anything really, guys. So I hope you learned something. Yeah, you could get the get bound incline rect, but then you still need to get the distance to this bound incline rect. Like, okay, you have this rect, you might have the mouse over, but then the distance, like when the mouse is not inside the bound incline rect, but you need to get the distance. And this is actually really nicely explained in the video by Nigo Kiles, and I will link this video on the stream. And this is one of his calculations. This is the part that I wanted to implement in this stream, but I think it's just getting too long, and I kind of want to stick with 1 hour, because 1 hour is even 1 hour is already too long for a video on YouTube. Nobody's watching 1 hour videos except you. And by the way, I'm gonna be creating like another playlist with short tips and tricks on dev, and maybe you will like those too. This is kind of what I wanted to show you today. This is an easy particle effect. I'm gonna bring back. This is kind of cool, and you could play with it. And you could of course draw this like in WebGL. What's the difference? We just set the physics, and the only part that concerns the Canvas2D is like this one. It's like when we draw, you just update positions, and it's going to be the same in 3D and same in Pixie.js and anywhere. So if the rendering is going to be slow for this one, and it will be, of course, just check. But eventually, if there's too many particles, it's going to be just too slow. Yeah. You could see it's already taken a lot of time. But you could do a lot of things to improve that. Like you could limit the number of particles, and that's what Mark did. There's actually only 150 particles on this particular case. So if I just move too fast, they stop appearing. Just appear 1 or 2 particles. If I go slow, there's a lot of particles. There's a couple of tricks you could do here. Yeah, I might share this code so you could play with it. So guys, thanks for watching. I hope it was educational, and I hope it was just a little bit entertaining too. I had some fun too, and I'll share the code and let me know what you played with, like what you did with it. And the thing is, it's really simple to do. Just go ahead and try and be creative with it, and you never know what you might arrive at. And I bet Mark experimented with those particles at his time, and then when the time came to build his own website, he just, okay, I can do the magic wand, I can do these particles, and he just had his tool in his belt. So yeah, have a good day or night or whatever the time it is at your location. Say kind words to someone. Say someone that you love him. Maybe parents, maybe your boyfriend, girlfriend, and live a good life. And I see you probably in a week with some other effects. Next time it's going to be probably WebGL. But still, you can let me know in the comments what you like more, like the WebGL or this more simple stuff like the Canvas2D. It's not that simple in the end, but still, it's kind of closer to the usual front end. And I'm gonna continue with my Sunday. See you in a week, guys.